Good morning, good afternoon, and good evening to all of our attendees joining us today for this latest Data Science Central webinar. This is Bill Voorhees, your host. I'm the editorial director with Data Science Central and also chief data scientist for Data Magnum. I'd like to start off our event today by thanking Tableau for their sponsorship today. Tableau is an integral supporter of the Data Science Central community, and we're honored to have them sponsoring our event today. I'd also like to take this opportunity to mention and show our appreciation for some of our other recent sponsors, including Alteryx, IBM, Teradata, Anodot, Dell Statistica, and Exaptive, to name just a few. Now, past webinars are available on demand at datasciencecentral.com, and if you haven't had the opportunity to view them, I encourage you to take a look. They provide some very useful insight into a wide variety of topics of interest to our data science community. Today's webinar is entitled The Science of Color and Visual Design Principles, to be presented by Tableau. And before we begin, I'd like to briefly review the format of today's webinar. Today's event will be an hour long. We have one presenter that I'll introduce in just a minute. There'll be 10 to 15 minutes of Q&A following the presentation. And this event is being recorded and will be available on datasciencecentral.com later this afternoon, following today's live event. Now, I'd also like to encourage our attendees to provide questions throughout the presentation, as we'll be presenting and reviewing them on your behalf during the Q&A portion of today's event. So I'm very pleased to introduce today's speaker, Maureen Stone. Maureen Stone is best known for her expertise in digital color and its applications. She also has broad experience in digital design, interactive graphics, and user interface design. She spent the first part of her career at Xerox Palo Alto Research Center, working on projects related to the then new fields of desktop publishing, digital document design, and digital printing. She's the author of A Field Guide to Digital Color, and her work at Tableau Research is focused on interaction between visual perception and design. In addition to her research, she offers both scientific and practical advice to development teams on all topics visual, from color selection to map design. She's been involved with Tableau since 2004, when she designed the initial color data colors for Tableau 1.5, and she joined the company in late 2011, was a founding member of the research team in 2012, and became a research manager in 2015. So in today's webinar, you'll learn how color science and visual design principles combine to create color palettes that are both beautiful and visually effective. Maureen will talk about principles and processes that Tableau software used to create new color palettes in the latest version of Tableau. So Maureen, with that, I'm going to turn it over to you. You can begin as soon as you're ready.
Thank you, Bill. So let me get this yellow button working, and here we go. Good morning and good evening to everyone. Thank you so much for logging on to hear me talk. The mission of Tableau is to help people see and understand their data, and my goal is to help with the see part. And in particular, what I'm going to talk to you about is how the design of color helps people not only see but also understand their data. As Bill said, I'm a member of Tableau Research. There's currently about a dozen of us. We have a website, research.tableau.com, that would let you read about our careers and our current papers. And there's about half of us in Palo Alto in the Tableau office there, and the rest in Seattle. So my story begins back in 2004. At the time, I had left Xerox PARC and I had been working as a consultant for about a decade. Our family had recently moved up to Seattle and I was looking for work. Now, I knew the Tableau founders and of Tableau, and so I was delighted when Jock McKinley, the director of research and design now, called me up and said, "We'd really like you to help us make our colors just absolutely world class." And I thought, what a fun project. But in the back of my mind, I was thinking, But unfortunately, that won't give me too much to do because colors for bar charts and lines, how hard can it be? Well, a lot of this talk is going to show you how hard it can be, how rewarding it is when it works. I'm going to talk, the abstract suggested I was going to talk primarily about the new colors. I'm actually going to talk about both the old and new colors and the design that goes behind them. So here's our roadmap. I'll talk about the design principles that we've established throughout the years. We started in 2004. I had various contracts up until I joined the company in 2011. About every year or so, they'd call up needing more colors. Towards the end of my contracting, I got more involved more broadly in user experience and was actually hired initially as a user experience designer, and then moved over to the research team once it was created. So throughout that time, we developed design principles, and then I'm going to give you some examples of different color types and how you think about their design, how it interacts with the visual system, and the like. And finally, I'm going to finish up with color vision deficiencies. In other words, how do you use color for people who are, quote, colorblind? So to start with the principles, our very first one is to focus on data, not on color design. We want our users to be thinking about their data. The color is there to help them see it. That actually affects strongly how we choose to present the colors. We don't just do a regular color picker, we create palettes. Now, even in the design of the visualization, we put data first. You can see here, these are the original Tableau colors. They're nice and bright and strong against the white background and the relatively light axes and labels. For Tableau 10, we made the overall visual design even more soft and elegant. And that was great motivation for taking the colors to something a little more subtle. So these are the new colors. Now, our second principle is that the colors need to be robust for multiple views and mark types. When someone like the New York Times creates a visualization, they design it and color it once they understand what they're actually showing, whether it's a map or a line graph. They think about the affect, sort of what is the topic about. In Tableau, we don't have that luxury. The default palettes at least need to work for all marks. They need to work in all visual cases. They need to be very generic. So let me show you some of the issues that brings up. So here are the kind of views we had in 2004. We had lines and bar charts and scatter plots. And I needed colors that were strong enough that those colored dots were distinguishable, but not so strong that the bars were screamingly bright. As the product moved on, we developed, and here's the new ones. As the product moved on, we developed more area graphs and had more and more trouble with the colors feeling screamingly bright. And so in fact, in some cases, like the map and the filled lines underneath, we're actually muting those colors back a little bit by adding a little bit of transparency to them. So one of the goals with the new colors was to deal with this extreme brightness problem while still getting things to be visually distinct. And so here's what we've done. And now I think you can see more strongly than in the lines and marks, bars, how the new colors have a very different overall feel. Now we want our users to be thinking about their data and their data analysis, and we want to by default, give them best practices, the best colors for the type of view they have. Now if the palettes are for what we call discrete data, where the point is to label individual lines or categories, then we give them discrete palettes. You can see the default palettes go all the way around the rainbow in the sense that we have a lot of different colors in them. And we also have the refinement that if you have a small number of different data items, we give you 10 colors, whereas if you have a larger number, we go up to 20. And the 10 is a better encoding and actually a better use of color for a low number of items. But if you go up to 20, we will give you 20. If you go above that, we're just going to start to repeat. Now, if your data is numbers instead of categories, then we give you gradients that run from dark to light to help you identify the quantity. We give you different colors depending on whether the numbers are positive, which are the blue ones, negative, the orange ones, or a mix of both. And finally, while we encourage best practices and give you that for default, we allow you to customize because people do want to allow their own personal expression, or they may have particular semantics they're trying to capture in the coloring. So to do that, we supply not only the default palettes, but a lot of palettes. So a lot of the design process is about being able to do a lot of them. We let people mix and match from the colors within the palettes. You don't have to take the whole palette. We allow people to drop into the color picker to customize individual colors. And we actually have an extensibility feature where by creating the correct XML and reading it in, you can actually create your own palettes. All right, so why do we use color in visualization? And Tufte, who has written many books about information design, has 4 principles, 4 purposes, 4 uses for color. And when you use color in a viz, it's important to keep track of which of these purposes you're trying to satisfy. The first is to label. So if I have a whole bunch of different marks and I want to be able to tell them apart, I label them with different colors. Just like if you were going to create, go look for a book in a bookshelf, you would find it easier if the books were different colors. The second principle is to measure, to show color as quantity, like I was showing in those gradients. A third is to represent or imitate reality. In other words, you're trying to get some sort of semantic mapping between the color and its meaning. So the blue of water in maps is an example of that, or the green of the parklands. In visualization, you may have colors associated with, say, teams or regions that are common within the company. In that case, you would like to go ahead and match that because that will help people's understanding. And finally, color is used to enliven or decorate. Color is beautiful. It is okay to use it just for beauty. But if you do this, you need to be sure that you don't muddle the other more functional purposes. All right. To label color as category. Here we have 8 or 10 categories, and you can tell the dots apart because I have labeled them with colors. Here I have an entire dashboard. The red is always the same thing within this dashboard, so I can see that the region, which is south, which is red, or the central, which is blue, is represented in 3 different graphs. As Tableau has 2 default palettes, we automatically apply them based on cardinality. And now I'm going to talk about the principles for designing those palettes. There are 3 main ones. One is that the colors need to be visually distinct at all sizes and relative to the background. That means you need to be able to tell them apart. This seems quite clear. They need to be easy to remember and to reference, and we want to make them beautiful. Now, I could talk in detail about the first 2 from a color science background perspective. I only have time to address one of them. I'm going to talk about making them easy to remember and reference. So if I asked you the name and color of these objects, I think most people would agree that the star is yellow and the box is blue and the disk is orange. These are common, simple, basic names. If I asked you to name these colors, from a perception standpoint, they're still visibly distinct, but the names are not so clear. The star is sort of a yellow-green. The box is a blue-green or a teal, or maybe it's a cyan. And the disc is, well, I don't know, is it red or orange or rust? Those are not basic names. It turns out that naming and the idea of basic names is fundamental to the way that we understand color. There has been research done, extensive research done, to build this mapping between language and names. Scientists Berlin and Kay have identified what they consider basic color names for English. What this means is that if you show people a whole bunch of color patches and ask them to use one word to identify them, they will come up with a common word for many of these patches. Some of them will be very basic, some of them will be more ambiguous, but these names keep reoccurring. So we have sort of your Crayola primaries, the red, orange, yellow, green, blue, and purple. We have two somewhat surprising ones, pink and brown, and then we have black, white, and gray. Furthermore, all languages have some set of basic names, and there's a great deal of commonality in what names languages have. Most European languages have this set. Russian has two basic names for blue. Japanese, on the other hand, has less clear distinction between blue and green. It's more contextual. So for the Tableau 10, one of the principles we had was we wanted to link them to basic names. Now this is the colors from 2004. This is the first set. And you can see the names sitting next to them. The yellow is really a yellow-green, and we did throw in one of the blue-greens, so the teal is possibly not really a basic name, but it's so visually distinct we used it to fill out the set. We didn't want to use black because it's too strong. We didn't want to use white because that's our background. When we went, and now the yellow is really greenish because that's what happens on a display when you take the yellow down and make it dark enough to give you really good text contrast. There is no dark yellow on the display. It gets to be this greenish color, and that's just a limitation of display technology. Now, when we went up to 20, we originally speculated we'd be using more of the kind of in-between colors. It turns out that made them very difficult to identify. What worked much, much better was to keep the names and make light-dark pairs, as you see. And as I've designed palettes throughout the years, I've discovered that really sticking to the basic names, if what you want is for people to instantly recognize them and talk about them, is an important thing. Now, when we moved to the new Tableau colors, we kept the names. We changed the order, and that was for aesthetic reasons, and a little bit for color blindness effectiveness. I'll talk about that later. I managed to get a better yellow. It's sacrificed a little bit in terms of if you draw text in this yellow, it's not as easy to read as the text in the old yellow, but drawing text in data colors is not very common. We kept the light-dark pairs, but one of the variations we did was in the old set. All of the 10 were in the 20 exactly. Here we did a little more adjusting. So if you follow the pink there, you can see that the pink in the 10 is not the same as, is neither of the two pinks that are in the 20. We basically took a medium pink in the 10 and then split it. So we held the names, but we changed the actual colors a bit. And here they are for comparison. And to finish this section, I'll just let you know that most of you probably have met the basic names long ago. That's what we have in the Crayola colors. And for basically the same reason. These are fundamental names, easy to understand. Easy to understand and remember, they link straight into language. In 2004, we designed all these different palettes, well, actually throughout the years. I won't go into them into detail, but we have our defaults. We have some special ones like traffic light and colorblind. We have what I call disjoint ones, which are using only a part of the color space. And we have some gradients, which are for ordered colors, so that it's an ordered set of categories. In 2016, we added more. We improved our tools, we got more people involved, and now we have lots of different colors, including some new styles so that you can have different kinds of look to your vizzes. As Tableau becomes more focused on allowing people to both analyze and present their data, we felt it was important to give people more colors by default. And now I want to move on to color as measure. So here, this map, the data is birth rate, and it runs from some low number to a high number. And by looking at this map, you can see that the highest birth rates are in Africa. So that is the value of color as value. Now, if we have both positive and negative, this is profit per state, then we use two colors, one color for the negative and one for the positive, and then a neutral color in the center where it's 0, or whatever threshold is important. So these are those principles summarized, and they come from cartography from a woman named Cynthia Brewer, who has a tool out on the web called the Color Brewer that you can see and explore. And the principles that have been designed are established are that small values are lighter than large values, and that if you have two sets of values, they should diverge from a 0 value. And these are examples of the ramps that Cynthia did back, that was about 2002, I think. We started with those ramps from Tableau, but then began to diverge from them as we discovered the difference between designing for choropleth maps and designing for marks. So we encode best practices by giving you these principles automatically. Those are the gradients that we supply. And we provide lots of choices. And here's the set. Now here's our principles for palettes again. And what I'm going to talk about here is how to make gradient color visually distinct. How do you find individual values? How well can you find individual values? Because that's the real challenge, besides just sort of the qualitative distribution. So there are 100 different shades of blue in that square. There are a bunch of little squares. They start from 0 in the upper left corner, and they go to full on down there by the 99. And there they're laid out in a gradient at the bottom, just as a continuous set of pixels. 100 different values. How many can you see? Now, while color science would say under ideal circumstances you can distinguish between any pair of them, what you can see in this viz is probably 10, right? You can see the vertical bands that you get. And this really has to do as much with color perception as with the spatial distribution. In other words, the fact that they're in a row and then there's this jump between the color in the top left and the next one over. Now, worse yet, if you scramble these colors, so it's exactly the same colors, but I have now scrambled them more like they would be in a viz, I would challenge you to identify 5 values, right? If I asked you, to kind of estimate what numbers between 0 and 99 went to those, you would probably only get 5 cases. And this is the big challenge using color to encode numbers. Now, if I put a little hue shift in this gradient, you might see 6. You at least get some help distinguishing. It feels like it's a little easier to see the values, at least to me. But we're still looking at a fairly low number of cases. So here's these 2 gradients on a map, the blue one and the turquoisey blue one. And again, I think you feel like maybe you see 5 or 6 values. So down in this part of Africa, I'm not sure if the cursor shows up, it probably doesn't. So down towards the south of Africa, we've got a dark area of like 3 or 4 countries. They are different, actually, but they pretty much look the same. And then most of Europe appears to be more or less the same color. So the color helps, the color shift helps. It is what we do by default. but it isn't solving the basic problem. And just to emphasize that, this is the same picture on the left, the color gradient, the blue to green. And then if I've stepped it, so if you look at the legend at the top, you see there's now actually only 5 distinct colors in this map. It doesn't look all that different. A little bit. So stepping your color when you're doing gradients is really useful. Stepping it very simply, like I've done, is less useful than being able to put those boundaries somewhere that's significant. And so that's one of the real keys to using color as value. You can get the order from just sort of applying it continuously, but if you're actually asking people to identify data values, you need to keep the total number small, and you want to put the breaks where you care about them. And the design of any good choropleth map will show you that in action. All right, the third example I'm going to talk about excuse me, is formatting and annotation colors. So in Tableau, we allow you to change your shading in your background. We actually allow you to change the color of the text and the lines. We also allow you to annotate by just writing some text or putting some marks on top of the viz. And these colors have a different UI. They just have this little picker that you see over on the left next to the yellow arrow. The annotation I'm pointing to on the right. But these colors need to be designed. They need to be designed in a way that they coordinate with the data colors. These are examples of the palettes that we raise. So to give you the right defaults, we're assuming a white background. So if you want to change the background, we assume that you want a light shade to change it to, because our colors in general, the vizes, are designed for a light background. And so conversely, if you want lines or text, you're going to need to use dark colors. So we don't offer you all the colors all the time. We offer you the colors that we think would be most valuable. Now, if you've probably seen little color pickers like this before, but they didn't have things grouped in threes like this. They just had a little array of these patches. Why groups of 3? Now let me run a little demo for you here. I've now shown you only the lightest colors of those groups of 3. Can you tell them apart? Even if you think you can tell them apart a little bit on your screen, that's because you've blown this picker up rather large. If you had done it at size, you would not be able to tell them apart because they're too light. This is a problem. When things get smaller, when the marks are smaller, the colors are less vivid. And this is what we were seeing before with the marks and the size when we had areas versus like lines and dots. This is a perceptual phenomenon. It's the same phenomenon as when you take that paint chip home and you look at it, you look at your walls, you think, I love this color. And then when you paint your walls, you think, oh my gosh, I should have gone about 3 shades lighter. All right, well that applies to visualization. Now if you slide up the set of 3, we have darker colors, which are easier to tell apart. And once more, these should be pretty straightforward. And the reason they're in groups of 3 is so the dark ones can label the light ones. Now, when I originally designed the background colors, they're light enough that we're having trouble in the picker. But when you apply them to the background of a viz, they're still awfully strong. I had a graphic designer, a visual designer, create some new colors, and that's the ones on the right. And now you can see, even with groups of 3, even at this size, it's very hard to tell them apart. So what did we do? Well, we adjusted the colors in the color picker to compensate for your perception. So we made them stronger in a way that suggests the colors that we're actually going to apply, but isn't exactly the same RGB values. And based on some of the research that I had been doing in this whole area of color and size, I was able to do this algorithmically. We didn't have to do this by hand. So, given a color picker, you see it over there on the left, so those are the slightly stronger and brighter colors, and there's the color that we apply, and it's a little challenging, but This is quite realistic. Underneath the cursor on the left is the color I selected, and you can see the color I applied, and I think it feels pretty much the same. So that's the end of my examples, and now I'm going to talk about color and accessibility. Color vision deficiency, or color blindness as it's sometimes called, is most commonly a problem seeing the difference between red and green. So here's a simulation. Here we have apples in the tree, and here's with someone with weak red-green color vision won't see the apples as quite as red. Now, if you're picking apples, the red was hardly the only thing that helped you see them. I don't think that it's going to be a serious problem. It's a problem if you use color as the only way to distinguish between two items of interest. Now, that simulation was for someone sort of typically mildly colorblind. There are people colorblind to this point, mostly men, while they usually quote 8% 8 to 11% of color vision deficiency, only about 1 or 2% are this badly colorblind. And now you can see that there are two cases, protanope and deuteranope, where you really don't see any distinction between red and green at all. It's just a matter of lightness. And it also, interestingly enough, even though a protanope is missing the long wavelength cone in the eye, you have 3 cones in your eye, and the deuteranope is missing the medium wavelength cone, the effect on their color vision is very similar. If you are missing the 3rd cone, which is a short wavelength cone that lets you see blues, you get a different kind of color blindness, whereas the red-green is a genetic problem. It's a recessive gene on the X chromosome, so the mother can carry it, but the sons are the ones who suffer. Tritanopia is a different, much rarer genetic disorder, and also weakness in that short wavelength cone comes more often with disease or injury. All right, so practically speaking, what happens if you consider accessibility is that color blindness is going to reduce your lovely 3-dimensional color wheel down to basically 2 colors, depending on what kind of color blindness you have. So if for the red-green color blindness, we have basically all colors become either blue or orange or yellow, where I'm going to call orange and yellow the same color. And whether you're a protanope or a deuteranope, it doesn't matter. You can see at the top there that the red for a protanope is darker. People with weakness in the long wavelength, that down at the red end, have generally more problems than people with weakness in the center. For example, I had a colleague who could not see red LEDs. Basically, he couldn't detect that ultra long red wavelength. Tritanopia is on a different axis, sort of the purple-yellow one, and you have sort of these 2 sets of colors available. All right, so let's put some of this into practice. What happens in practice? The most important thing that happens for visualization is that it reduces the color namespace. That's what color blindness does, or color vision deficiency. While a lot of people think it's about red-green, since most people have it only mildly, a strong red and a strong green are actually distinguishable. What's not easy to distinguish is colors that differ by a small addition of green or red. So the difference between blue and purple, for example. For the normally sighted, those are 2 visually distinct color names, but to anyone with any weakness in their red sensitivity, they are the same color. Surprisingly enough, green, yellow, and orange all collide. Similarly, brown, and so you can't see the difference between green and blue-green. That's kind of obvious that they collide at the orange and yellow. I'd have to get more into your cone sensitivities to explain that, but practically speaking, they do. Now, the red is easy enough, but the brown and the difference between brown and gray are simply a little red. So I have a colleague who complains most bitterly that people think brown is a different color because to him it is not. So how do we do with our default colors for color blindness? So I've given you a gradient as you move from left to right. And so you can see that those first 4 colors remain distinctive for the first 2 steps. And now by the time, even by the 3rd step, because of the difference in lightness, you can tell them apart. But much beyond that, we're really starting to duplicate colors. So you can't use the entire 10 and be accessible. For red, in general, the whole blue, orange, gray range is safe. And so this is my recommendation if you're going to use color, is to stick with this. And we support this in Tableau by creating a colorblind palette, excuse me, that is shades of these colors. And so to run the same sort of gradient on that, you can see that these remain more distinct because I've been more careful about the lightness and because they're just generally more distinctive colors. You don't lose the difference between the bluish ones and the orangish ones. And here it is for Tritanopia. You get a different partitioning in terms of the default colors, but it isn't, it's still distinguishable. The best guidelines is to not use color alone. So for something like a scatter plot, if you really need to be accessible, you should double encode, both a combination of color and shape. You should always be aware of lightness variation. A standard thing in the design world is called get it right in black and white. As you can see, this map works perfectly well as a black and white or grayscale rendering. The color enhances it, but isn't critical. And in fact, in your visual system, the perception of color is very quickly split into a perception of lightness, which goes to one part of your brain, and a perception of color, which is overlaid. The brightness, the shape, along with motion, goes to the part of your brain that has to work very, very quickly for that saber-toothed tiger that might be going to eat you. Whereas color is more about distinguishing things when you have a little more time to think about them. So here are the rules for accessibility, and these are taken from the ISO guidelines. Never use color alone for critical encoding. So always double encode with shape. Practically speaking, you can also encode with lightness. I'm not sure that will get you past the accessibility guidelines, so you need to label things. So that's the second, is to get it right in black and white. And then blue, gray, orange are your safest colors. So this is the end of my talk. I've left plenty of time for questions. I've talked about designing colors for Tableau and tried to give you a flavor of some of the color science and design principles that go with it. And I've talked about accessibility and color vision deficiencies. And so we're now live for questions, and back to Bill.
Well, Maureen, thank you so much for that excellent presentation. We'll get started with today's Q&A, and I want to thank the audience for their participation. We've had a great many questions that have come in during the presentation, and we'll do our best to get through all of them in the time remaining. And during this Q&A session, I'll leave up this screen with contact information for Maureen if you'd like to contact her following today's webinar. So let's get started. Maureen, I learned a lot about color that I didn't know before. Let me start with just a very general question. How on earth did you go about collaborating with visual design for all these new colors?
Oh, that's an excellent question, Bill. Back when I was talking about making colors, the rules for palettes, that last one was make it beautiful. And that's where the visual design expertise at Tableau was really, really helpful. When I did the first ones, I did them pretty much by myself with input from other engineers and scientists. But now we have a visual design team that can help us. To do that, I created a collaborative tool. I built it in JavaScript that would help you design an entire palette, and it was very easy to bring colors in and out. While the tool was very powerful and I don't even show it because it's got so many knobs on it, it's hard to explain. It was something that the visual designers could use as well, and so we could just pass palettes back and forth. And that way we were able to iterate and finally get to a point that we were all satisfied. The manager that was working with us was surprised that we actually managed to get this meeting of minds between the visual designers and the color scientists, but we achieved it.
Well, that's terrific. Oh, interesting. You know, we've had a number of very specific questions come in from the audience, so let me present those to you and have your comments. You know, one of our audience members asks about using high contrast palettes. What's your opinion of using high contrast palettes?
High contrast palettes are really important for people with any sort of fogging in their eyes or blurring because it makes it much easier to see edges. And that's the sort of the trade-off with the sort of softness of the colors that we produced. It isn't as easy. They don't have as much contrast as the old ones. It's a functional thing. The trade-off between the aesthetics and the actual function is always going to be with us. Our colors do meet accessibility guidelines for marks, but not most of the top palette would not meet accessibility. No, that's not true. About half the palette would meet accessibility for text.
Mm-hmm. Excellent. Well, thank you. And here's another very specific question, I think kind of along the same line. And that is, why did you decide to use alerting colors, red, orange, for the default categorical comparisons, and why red, orange, green together as the first set of defaults?
So in the original, see, I'm trying to parse that because I think the first two colors are blue-orange, right?
Well, the audience member asked, they identified the alerting colors as red-orange as ones that you had used in categorical comparisons.
So we didn't think of them as alerting colors. We use the blue-orange because they're colorblind safe. And then I am, and they're also somewhat of the Tableau brand. So orange is simply the opposite of blue, and it gives you sort of maximum discriminability. The red, being next rather than green, is again a more of an accessibility thing and somewhat of an aesthetic thing because when you add the teal, that's what looks good. So I guess what I'm hearing is that that audience member feels that there are more semantics on these basic colors that I really wasn't reading into it. I guess I can't say much more than that. They should feel free to type back and clarify their question.
Right, right. Now, what would happen to your choice of color palette if, for example, you went from a light background to a dark background?
Here I would have to take and use a lot more light colors, yellow, light bright cyan, a light green instead. That is a weakness in the current design that we haven't yet addressed the fact that people more and more do use dark backgrounds. Now, I recommend for general usage that the white, using a white background, it's easier on your visual system because the white gives you both something to focus on and also kind of sets your color perception is always relative to the white, so it's good to have a white in your field of view. Otherwise, your cones are kind of wandering around trying to find their null point. However, on some environments, people do like to use a charcoal gray. I don't ever recommend a pure black. And for that, we should really be designing them some better and lighter colors.
Oh, interesting. Interesting. Now, here's an interesting take from an audience member that I hadn't thought of. There are some emotional or meaning connotations to some colors in our culture, like red for stop or red for danger and green for good. Are those useful things to consider, or do we just get into too much cross-cultural territory when we start to do that sort of thing?
I think that including the emotional content of color is important within the design of a specific viz. So we call this affect, and I've actually been doing some research with people up at Simon Fraser University on color and affect and whether we can, given that you want a particular affect like calm or exciting, could we give you suggestions as to what color sets would be most likely to convey that? I don't want to get as much into the affect of individual colors, like red meaning danger, because that's not cross-cultural, actually. Red is celebratory in Asia, for example. Mm-hmm. And so that feels a little bit like a rabbit hole you would go down by the time you try to satisfy everyone. But in terms of letting people choose and create more palettes, you can certainly control kind of the overall feel of the viz very much by your choice of colors.
Okay, well, thank you. Now, one of the things that we observed in your presentation was that over time, you guided Tableau toward I guess what I would call a more muted or less vibrant palette. Does that mean that primary colors are simply too bright to be useful? And along that same line, what is the difference between modern color theory and what used to happen that caused you to go in that direction?
So when I did the pull to the lighter, softer appearance or affect was a big pull from visual design for Tableau as a whole. They felt that this gave us a modern, more sophisticated look. It's part of Tableau's goals for people to take and do their analysis and then be able to present that straight away, maybe with some minor modifications and simplifications, because we feel that the communication of your results is as important as the discovery. In 2004, the colors that we picked were actually muted relative to kind of the standard way people, at least in computer science, picked colors, which were much more screamingly bright. And so we've continued that trend. We leave the classic palettes in the choices for people who prefer the stronger colors and also for backwards compatibility with the old workbooks. But again, this is part of the to beautify in terms of the functions. And here I was mostly following the lead of the visual design people. You should have seen how muted they wanted them originally, so we reached a compromise.
Mm-hmm. Well, that's interesting. Yeah, and I'm sure any time you have two strongly opinionated people trying to decide on a color, there's bound to be a lot of conversation. Now,
well, but I think it's a very useful balance, that the idea that color does, that beauty is part of the use of color. You're going to be staring at these things all day, so they should look good.
Right, indeed. Now, one of the things that your presentation did that frankly I wasn't sensitive to, and a number of the audience members have commented on, is really raised our awareness to this issue of the 8% of the population that is color vision deficient. And one of our audience members has actually asked, is there a way for a designer to simulate color blindness types so that they can see how their color palette would look to those folks?
Oh, absolutely. If you look for color vision deficiency simulators on the web or color blindness, you'll find a whole number of them. I don't know where the best way to do this, Bill. I have a favorite, but I've used 2 or 3 in this presentation. And I even within those who are visual designers and use the Adobe tools, like Illustrator and Photoshop, you can get these extremes, like, let's see, where is it? Like this. You can get these images from Photoshop, for example. It's one of the view parameters. There's one that you can throw into any web browser called No Coffee. There's one from Japan that's my favorite, but it doesn't have a simple name. So that is, I should probably put that into my recommendations, is use the color blindness, a CVD simulator.
Yeah, I was completely unaware that those were available. That's very interesting.
Is there a place for me to send you links that could go into this final presentation or not?
Well, you can certainly respond to the folks by name who have submitted these questions after the presentation, or they're welcome to write to you directly using the email address that we've displayed on the screen earlier, and I'll move back to in just a minute. Matter of fact, let me move back there now so that folks that have that particular question can perhaps email you and ask you that directly. The other thing that really I hadn't thought much about was the issue of color naming and how we can get to 10 or 11 names pretty simply, but beyond that it becomes much more difficult. What sort of research have you done on color names, and how does that impact where you've gone with this?
So I've done a bunch of research, well, a couple of different papers, which you can find on the website, about the value of not so much the basic names, but of linking the semantics of the name to of the color to the data that you're showing. So the classic example is if I'm giving you a bar chart of the caloric content of different vegetables, if I make the lettuce green and the carrots orange and the eggplants purple, it's pretty quick to understand. If I swap those around so that you have to remember, oh, in this viz, carrots are purple, people noticeably slow down. So when there is a strong semantic linking, then you really should align the two. The basic names work has been more qualitative, but it does keep coming back to the fact that when you're going generic, that's what people really need to be able to talk about it. We did end up with some, let's see, it relates a little bit when if you are actually doing visualizations of things that are color names. Now, I do that, and that's fairly exotic, but you could be Pantone or Crayola, for example, doing that. That would be a case where, obviously, you should line up the names and the basic names. It doesn't matter if I matched exactly your blue, but it better be a blue, otherwise it's going to break your brain while you try to think about it.
Right. Well, that naming is something that we'll have to think a lot more about. One of our audience members asked, and apparently has actually a preference for using black and whites and shades of gray, and wanted your comment on whether or not you found color sometimes distracting, and whether or not just doing things in black and white and shades of gray might be more clear.
Certainly get it right in black and white is a key principle, and you should be able to make your viz read beautifully without the shades of color. But if you're trying for labeling, then our ability to see shades of gray or shades of any color is limited, like I was showing in the quantitative colors. You probably can't go up to more than 5. And so if you want to push out to 10 or even 20, then you're going to have to add some hue. Another tip, which this person probably already knows, is that you can make gray much more beautiful and somewhat more different by tinting it. So instead of being an absolute pure gray equal RGB, letting it be a little on the warm side or on the cool side. And actually in the Tableau 10, that's one of the little nuances that the designer put in. The gray the light gray is kind of a stone brownish color, and the dark gray is more bluish, and it just makes them look better, and it's actually a little easier to see. In our palette of 5 grays, there's tints to those grays as well.
Well, that's very interesting. Now, we touched a minute ago on the emotional or philosophical value of colors, and if you are preparing for an international audience where, for example, red in the United States means one thing but has a different connotation than in Asia, what are some best practices that we can use to help us get across those cultural gaps, and what things specifically should we avoid in order not to create confusion?
That's a really interesting question. I would argue that for a very wide audience, you might be worrying more about color vision deficiencies, in which case you're going to sit into a very lovely blue, gray, orange palette, which seems to have less cultural weight. I think part of it is, for the visualization itself, you want to be sure that you don't assume that you're counting on the cultural association of like red for alerting. I mean, I think that that's universally recognized, even if it's not completely cultural, but you want to be sure that you label it, to be sure that it's clear and consistent, not just count on people saying, oh, there's a blinking red light, it must be a problem, especially for those people who can't see the blinking red light.
Yeah, excellent. Excellent. Do you think it would ever be possible to completely automate color palette design?
I don't think you can completely automate it, but you could get people started. So there is some research at Brown University. The project is called Colorgorical. So it's an automated system for creating categorical palettes. What it has is a bunch of sliders that says, well, do I care most about distinctness? Do I care most about aesthetics? So they have a model for aesthetics. Do I care most about, and then some settings. Do you want to specifically pick different parts of the color space to restrict yourself to? And then it uses I'm not sure if you would call it machine learning. What it is a whole bunch of, it rolls the dice and pulls out a whole bunch of different palettes, and then it weights them by some sort of model. It says which of these would be the best. You also give it the numbers. Now, if I did that first and then let you tune them, you'd probably design your palette faster. Another way to do it is to use constraints within the design tool. But the design tool I used counted instead more on simply showing you a lot of the different cases that you would have. So I would say semi-automated. I think that the work that I've done up at Simon Fraser, this was on trying to make sort of control the lightness of grids and other sort of subtle visualizations, said basically if you can keep people out of the areas that clearly won't work, then they will be happy tweaking within the domain that will work. So if you can set up the constraints, then you can actually make it semi-automatic.
Well, you've certainly shown us that color science is much more complex than I realized. Some of our audience members have asked, first, where can they learn more about color science in general? And second, you talked about Tufte, which is a resource that many of us know. Are there any other resources other than him that you would recommend? I have my book called The Field Guide to Digital Color, which is to trying to teach people sort of the domain of color, kind of how there are many different fields there are. For those interested in it's a breadth first search through a fairly wide area of technical fields. There's some stuff there. I have some essays and things on my website, some blogs. We have, outside of me, Gar Reynolds has lovely things to say about presentation design. There's a new book out by Teresa Marie Rhine about using color science for design. And there's a number of online resources as well. People have good recommendations for how to build palettes and the like. Or was the question more about color science, Bill? I'm sorry. No, I think you covered it.
Okay,
and to
good.
the extent that folks are interested in having you repeat those, they can reach you by email. But Maureen, I want to thank you for some great answers to some very good questions. And for those of you that asked questions today that weren't answered, we'll be sending all the unanswered questions to Maureen and the Tableau team so that they can follow up with you after today's webinar.
Okay.
I have just a few quick announcements. If you'd please mark your calendars for December 8th, that's our next Data Science Central webinar, which is Streamlining Analytic Processes to Boost Productivity, and that'll be presented by Alteryx. So just want to remind you that today's taping will be available for on-demand viewing later today, and that you can find that on the home page of Data Science Central in the Webinar tab located at the top of the page. Now, this brings today's webinar to a close. And I'd like to thank our audience for their attendance and thoughtful questions, and a special thanks again to Tableau for their sponsorship, and our speaker today, Maureen Stone, for insight into today's topic. Now, my name is Bill Voorhees, and I'm very pleased to have been your host for today's event, and I look forward to seeing you all again on December 8th. Have a great day.